now we will proceed to the actual second session. Oh, sorry, first session, first panel session of the conference. And I will now give the floor to Ewa Siedlecka from Gdańsk University, professor of chemistry at Gdańsk University, and Ewa is also a vice president of Polish Ecological Club Pomeranian branch currently. And Ewa has been working with microplastics for a number of years already, and right now she's more into pharmaceuticals, yet another has this substances element that is quite widely addressed as a hot topic all around Europe, I would say, and not only, and in CCB's work as well. And Ewa will talk about myths and truths behind microplastic pollution. So Ewa, the floor is yours. And
thank you very much for the introduction, and also thank you, Misha and other colleagues, for inviting us as a Polish Ecological Club for this project. It was a very good experience, not only for us, but also for the young people, for my students, because we also participating in this monitoring of the rivers. So thank you once again. And so my presentation is titled Myths and Facts of Microplastics. But maybe I start at first, I say a few words about the plastic, because next slide, please. Next slide, please. Yeah, okay. Because the plastic is a miracle, it is a magic material. It is lightweight and durable. It is can be transparent or colored, and can be molded to endless shape and size. So plastic is widely used in the packaging of food and household products. In addition, it is used in construction, electrical and electronics, textiles, furniture, and many other products. So plastic in the form of microbeads is also used in the beauty products, toothpaste, face wash, and detergent. It is essential material in healthcare and research. So it is hard to imagine a life without plastic, because now it is a substitute of many conventional materials such as glass, wood, paper, and steel in many applications. But the problem is that plastic was designed in the 50s to last forever, while one day we decided to use this indestructible product as a disposable material. So now it is time to change our thinking about plastic, because it is not a single-use material. So this project was also about it. The environment is polluted by micro and macro plastics. And at first, the plastic contaminant discussion was focused on microflakes. And they come from a breakdown of large pieces of plastic material. And in last decade, the discussion was shifted to microbeads, when it was found that beauty products were the major source of microplastic in wastewater. However, most of microplastics found in the water bodies come not from the breakdown of large pieces of plastic materials or from the personal care products or beauty products, but from textiles and clothing. In 2011, researchers reported about huge amounts of microfibers in our water bodies, seas, and oceans. And as you can see in this picture, the synthetic textiles, the microfibers from synthetic textiles, it is 35% of total microliters in the wastewater. And it is also very important that microbeads in this personal care product, as well as microfibers, both contribute in the environmental debris, but in the immensely different scale. Because these microbeads, which are in the personal care product, it is only the 2% of total microplastics in water. So that means that our clothes and washing machines are large contributors of microplastic pollution. Additionally, the city dust and tire dust are also the major source of microplastics. It is 24 and 28% respectively. Okay, so next slide, please. Okay, yeah, on this picture you can see the microbeads, microfibers, and hello? Can you hear me?
Yes, yes, all good.
Okay.
Please go ahead.
Yeah. So on this slide you can see the microbeads, microfibers, and fragments of microplastics. And as you can see, the fragment is very sharp. So it means that such a fragment can be hurt the organic organisms, and they are very dangerous, much more dangerous probably than microbeads and microfibers. And next slide, please. Is microplastic removed in wastewater treatment plants? Yes, it is. Research conducted in the Europe shows that wastewater treatment plants can remove up to 99% of all microbeads. But what about the microfibers? They are also removed in the wastewater treatment plant by less effectively. They are eliminated in range of 40 to 85%. So generally, the total microplastics count can reduce by 75 to 99% through treatment. What is very interesting that preliminary screening and primary clarification remove the huge amount of these microliters from 75 to 85%. Depending on density, these microplastics can be removed by flotation or by sedimentation. So it means that treated wastewater likely emits less mass of microplastics than a non-point source of microplastics. Next slide, please. But if even the local wastewater plant effectively eliminated all the fibers and microbeads, so this indicated they are effectively collected in the sludge. Due to the microplastics are stable in digested sludge, they may negatively affect subsequent treatment and disposal of sludge. Additionally, a European community permits land use of sludge because it is a good fertilizer. It's okay. However, a great number of micropollutants may be secondary released into the ecosystem in which microplastics can cause potential biological toxicity. Next slide. Oh, and here you have also the picture where the shapes of microplastics in the water body are presented, and you can see that in the wastewater and also in the water body, the microfibers are the major fraction. How do microplastics affect the environment? This is a very important question. So microplastics both absorb and give off chemicals and harmful pollutants. We know that many persistent organic pollutants, such as pharmaceuticals, dioxins, pesticides, and others, exist in the oceans and seas at very low concentration. It is nanograms per liter. Due to their hydrophobic nature, they can concentrate it on the surface of plastic particles. Because these plastic particles also characterize the hydrophobic nature, and they interact with one to each other. Microplastics are commonly mistaken for food by marine animals, as they are colorful and resemble actual piece of food. And marine animals ingest the microplastic, what can lead to digestive blockage or internal damage from abrasion. And as I show you, this fragment of irregular shape, very sharp, are very dangerous. On the other side, the plastic degrades in the environment, and they release monomers, for example, bisphenol A, and also release additives such as phthalates, which can then be absorbed by marine organisms. And the next slide, please, because on the next slide you can see the possibility effect of microplastics on fish. And we know that this monomers like bisphenol A or phthalate have a negative effect on the water organism, aquatic organism, and this negative effect is on the endocrine system, immune system, and they also can be accumulated in the liver or in the muscle. But it is very important to note that the concentration of particles detected in the natural environment are order of magnitude lower than those reported to affect feeding, reproduction, growth, tissue implementation, and morality in organisms. So we don't know exactly what the concentration of microplastics in water bodies is the safe for aquatic life. This is very important questions because everything depends on the dose. It is the same as for the toxic substances. And what the concentration of microplastics is enough to be harmful. Therefore, there is still much research needed to properly evaluate this issue. Next slide, please. Yeah. So, but we know that size is very important when we talk about the toxicity. By definition, microplastics are plastic particles less than 5 millimeters in size, but we suppose that nanoplastics with particles less than 1 millimeter or less than 100 nanometers are much more dangerous. Why? Because they can infiltrate to issues. And when the particles of microplastics can absorb from the surface the toxic compounds, so they also, with this particle, infiltrate to tissues. Because microplastics and nanoplastics are commonly presented in wastewater, so microbial community in activated sludge is a good object to study the influence of microplastics on environment and also on the living organisms in the environment. Reported studies showed that when the size of microplastics reached the nanometer level, they have acute inhibitory effects on microbial community, key enzymes, and metabolic final products. In addition, microplastics reduce the diversity of biological communities and the amount of toxicity microorganisms in activated sludge. The absorption of environmental micropollutants and the release of additives makes the influence mechanism of microplastic on the wastewater and sludge treatment more complicated. And next slide, please. So what about humans? Because we also eat microplastics, and also in our organisms the microplastics were found. So human beings could mainly be exposed to micro and nanoplastics, which, as I mentioned previously, are much more dangerous. So be exposed to this micro and nanoplastics orally and by inhalation. And it is possible toxic effects of plastic particles are due to the potential toxicity of plastics themselves and their combined toxicity with released additives and absorbed contaminants. The toxic mechanism could involve oxidative stress, the inflammatory reactions, and metabolism disorder. It is a reason why we suppose that obesity and diabetes may be associated with the presence of the microplastics in the food. So, summarize, more studies are needed to carry out and explore the potential toxicological mechanism of micro and nanoplastics on living organisms, including humans. In our study, which was presented by Evgeny, we only can monitor the microplastics because the nanoplastics have characterized the too small size. And next slide, please. And last but not least thing, should all plastics be banned? It is true that plastic is an environmental problem and that we are afraid of our health. But plastic is also a useful raw material in many branches of industry, what was shown in the introduction of my presentation. So plastic is lightweight and durable, and it is essential material in healthcare. We are currently experiencing during what we are experiencing during the COVID-19 pandemic. Eliminating plastic from our society altogether would be nearly impossible. For example, the plastic materials are used for a widely variety of transportation applications. Thermoplastic offers a number of advantages over metal, wood, and fiberglass. And plastic are also extremely lightweight, which contributes to improved fuel economy. So, summarizing all my presentation, our knowledge about microplastics and nanoplastics is still not enough. So the monitoring, not only by the scientists, but also by the students and young people, is very important. And there's an urgent need for more holistic monitoring studies on the particle size and material type that are actually in the environment, and also the long-term studies, their effect on living organisms are also needed. And thank you very much for your attention.
Thanks a lot, Eva, for this really interesting presentation that I would say serves also for the purpose of very broad awareness raising. So it's not really addressing, say, technical experts, but more to a wider audience. And I'm really happy that we have a range of materials that we can share